This is the video tutorial for the Simplifying Fractions Worksheet A. The reasoning for me giving you this worksheet and actually going through it with you, we do a lot of these in class, is that I know that everybody's perfectly capable of doing fractional operations. That would be add, subtract, multiply, and divide. However, that being said, a lot of people have a bad habit, and that would be to not simplify their answers. And one might ask themselves, well, why do I have to simplify it in the first place? It is correct, you know. And I would just come back with this, you know, it's not that we're lazy, and I always joke about I am lazy and I value my time, and that's the deal. And you might say, well, it takes more time to simplify. Here's the issue. You tend to do a lot of fractional operations in math, especially in the future, and it's just much easier to deal with smaller numbers. And honestly, what I'm getting at is, once you get really good at these things, and it may not be this year, it may not be next year, it may not be until your senior year of high school or college, but you typically do these operations in your head. And it's much easier to deal with smaller numbers, believe it or not. You know, that's the truth. So, hey, a few things that I need you to know how to do, starting with, I put down the example problems that were actually done for you on the worksheet. So you can look along with me, and I'll show you how I came about my calculations. But the two things we want to make sure we know how to do are reduce fractions. If at all possible, if they have a common factor between the numerator and the denominator, let's divide that sucker out, because it's not necessary to have that in there. You know, remember, two equivalent fractions exist if and only if there exists a scale factor between them, and we call those fractions proportional. So a direct example of what I'm talking about is the first example I've given you on this paper. Now you notice 4/18. Here's the thing, if I were to draw a picture of, say, a rectangle with 18 equal-sized pieces in it, and I were to color in 4 of those pieces, the neat thing would be that I could draw a similar rectangle, or actually a congruent rectangle, shade in the same portion, and have only 9 pieces in it, and color in 2 of those 9 pieces, and still have the same amount shaded in. The question is, how did I get that? So here's the one thing we always want to pick on, and I didn't show you this on the worksheet, but I'm showing it to you here, so that hopefully you can comprehend this a little bit better. You know, I look at this fraction here, I say 4/18, and some of you already notice, hey, what do the numerator and the denominator have in common in terms of a factor? Okay, well, think about all the numbers that go into 4. 1 and 4 and 2 and 2. Okay, and when I say 2 and 2, I mean 2 times 2, and 1 and 4, I mean 1 times 4. Also 18, I say, okay, well, 1 times 18, but also 2 times 9 as well. And already I've determined that they both share a common factor of 2. Now, I know that sounds silly. I know this is really silly, this problem, but it's actually necessary. And I know some of you just looked at it and said, well, hey, they're both even. 2 is a common factor. Here's what I'd like to do. I'd like to just break these up into factors and show you that the top really is the same thing as 2 times 2. I'm not expecting you to do this. I'm just doing this to illustrate my point. I know the bottom is also 2 times 9. Now, whether you're watching this video after we've done some fractional products or before you've done fractional products, you're just going to have to trust me here. But the neat thing is, remember, product means the answer to a multiplication problem. When you multiply 2 fractions, we do it just straight across. What I mean is this. If I could break this up, this is the same thing as 2 halves, and I'm just taking these 2 2's right here, okay, and I'm multiplying that by 2 9ths. This is indirectly and implicitly what we are doing when we look at this, and I would challenge you to think about what 2 halves really is. You know, and of course, anything over itself or anything divided by itself, because remember, a fraction is a division problem, excuse me, is 1 whole. And then furthermore, to think about, well, what happens when you take anything times 1? It maintains itself. We call 1 the multiplicative identity, because if you took anything times 1, it maintains its identity. So I look at this and I say, well, 1 times 2 9ths, that would just be 2 9ths. Now, you've heard me say this before, but genius is being able to go from point A to point C without having to go through point B. That's also laziness, and that's okay, because in math we want to make things as simple as possible. No pun intended. But my question is, how did I go directly from 4/18 to 2 9ths? And I know we do this in class a lot, so forgive me for breaking it down this simplistically. But I noticed that 2 went into both of these. Honestly, what I just did was I took the numerator and the denominator, and showing my work, I would have drawn arrows. You know, this is a good habit to have. And I would say, here's the operation that I carried out. And recall that this scale factor here, I did the same thing to the top that I did to the bottom. I'll give you an analogy. Imagine that you took a picture of yourself, and you made it half the width, but you made it 1/3 the height. It would look distorted. you want to do to one thing what you do to the other to maintain similarity, and in this case, equality. So we say these two fractions form a proportion because they are equal. Here's the deal. I just need you looking at these problems and saying, is there a number I can divide out of both of those? Is there a number they both have in common? And I need you to resist the urge to do something like this, which would be, hey, say 9 goes into 18, let's divide 18 by 9, and that would result in having a 2 in the denominator. And forgive me for this, but I know 4 ninths off the top of my head, or 4 divided by 9, would be 0.444444. We say that a fraction such as this one, even if I put the bar over it, is not in simplest form because, hey, how could you call a fraction that includes a decimal in it simple? It just is not an easy thing to do in your head. Okay, so look for common factors and divide them out. So this problem resulted in 2 ninths. Hey, moving on, what I'm going to do is I'm going to give you a lot of mixed numbers. Recall that a mixed number is a combination of a whole number, a whole part, and a fractional part. And this fractional part is typically always proper. Okay, so I look at this and I say, what I'd like to do is change this into an improper fraction. In other words, you just want to take all of your whole numbers here and think about it as money and break it into change and make this completely into change or fractional part. So here's what I know. 4 wholes, that's the same as 1 plus 1 plus 1 plus 1. And if I were to break this up into thirds, I think you would agree with me, and I'm not asking you to do it this way, but I just want to illustrate that 4 wholes is the same as 3/3 plus another 3/3 plus another 3/3 plus, you got it, another 3/3, and then I'll tack on my 2/3. Okay? For a grand total of, well, remember 3 times 4 is 12 plus another 2. That's 14/3. Here's what I would like to do. I would like to go directly from a mixed number straight to the improper fraction without having to think about this very hard. And recall that I just said, hey, 4 times 3, and the reasoning behind this is because I said, well, how many thirds are in 4 wholes? Well, there are 3/3 for every 1 whole, and since there are 4 wholes, let's take 3 times 4. Literally, we start to see this pattern emerge. Just take your whole number times your denominator, and once you get that product, which in this instance is 12, add that to the numerator. That's how I'm getting my 14, and just notice that the denominator stayed the same. This is an extremely common theme with fractions, is that denominators maintain themselves because we're not changing the size of the pieces typically. We're just messing around with how many of those pieces we have. Last but not least, we need a method to go from a mixed number back to an improper fraction, where the numerator is bigger than the denominator, back to a mixed number, such as in this case. Now you'll notice on example 3 in that last and final section, I always recommend that if you're going to change from an improper fraction to a mixed number, always look for first if you can actually divide out factors. And yeah, hey, carrying the theme from this one down to this one, these are both even. So the first thing I'm going to do is I'm going to split these both in half. It's not that I always split fractions in half, it's just that 2 was a common factor. So I divide 2 out of both of these, and I hope you can read that. I wrote it kind of small. Divide by 2, divide by 2, you do the top what you do the bottom. Instantly I know half of 10, or 10 divided by 2 is 5, or 2 goes into 10 5 times. You might have to stop and think about this one. Maybe you do it in pieces. You say, well, half of 100 is 50, half of 14 is 7, okay, so 57. Here's the deal. This is the same thing that's written here. But what I want to know is, okay, well, how many times would 5 go into 57 evenly? Now, for the sake of time, I'm just going to let you know. But I would suggest, actually, no, we'll do the long division. Let's take 57. This is appropriate. And find out how many times it does go in. And we are actually concerned with the remainder here. You don't have to get a decimal on this type of problem. So we say 5 goes into itself, of course, 1 time. 1 times 5 is 5. If we take that difference, there's nothing left over, but of course we have to go until at least we get to the decimal, or there's nothing left over. 5 does go into 7 1 time, so 1 times 5 is 5, the difference here being 2, and I'm actually going to circle that because here's what I was looking for. How many times did it go in evenly? Because for every 5/5 it produces 1 whole. Hey, our quotient here was 11. So this is the same as 11 wholes, and notice that denominator stays the same, and we had 2 of those fifths left over. Simply put, here's all I did. I took 57 divided by 5 and put the leftover as this fraction over here. Okay, so we need to go from mixed number to improper and improper to mixed number, and there are 2 different methods for doing so. We have to be really good at the simplifying thing. Okay, so take this worksheet very seriously because I cannot count you right, or even if you have a correct answer, if you did not simplify it, and that breaks my heart when I have to do that. Good luck on the homework.